All right, now with the explanation of what dynamic range is out of the way, we can go ahead and jump right into the photographs. And so what I have here are 6 photographs, 3 taken with each camera, and for each pair of photographs I shot the exact same scene with the same framing and the same focal length, as well as the identical exposure. And so for the Canon body, I've used its 18-55 IS kit lens, and for the Nikon body, I used its equivalent 18-55 VR kit lens. And so we're comparing the same class of bodies as well as the same class of lenses. So here's the first photograph. This is a photo shot at an aperture of f8 with a shutter of 1/60th, again at base ISO with a focal length of 18 millimeters. The Canon image is on the left and the Nikon image is on the right. And so what I've done here is expose the photograph so that the highlight is just below the clipping point within the exposure. And so in this case, the highlight is the light coming in from this window. And so this is an interior scene of a room that's illuminated by the morning sun coming through this window. And so the highlight areas, which are some of the bright values within the scene outside the window, as well as some of the reflective highlights on the scene, are what I've exposed for. I wanted to render these highlights without any loss of detail. I didn't want those to be clipped. Now you can see what the end result of that though is, and this is typical of a high contrast scene. By exposing for these highlights, you've now completely underexposed the mid and lower shadow areas of that image. In order to account for that and correct that, you need to, in post, elevate those shadows to lift their exposure values up close to where the mid and highlight areas are. And you do that within a tool like this in Lightroom, where you adjust the exposure of the shadows. So now I'll go ahead and show you what these photographs look like after I post-process them to increase the exposure of the shadows. And again, this is the step that's necessary in order to utilize the full dynamic range of the sensor. All right, here's the result of that post-processing. We've got the Nikon now, the image is on the left, and the Canon image is on the right. And so you can see here I've elevated the exposure of the shadows to sort of blend in with that outdoor exposure. So now it almost appears as if the scene was evenly illuminated without that high contrast between the outdoor scene and the indoor scene. And this is, for this particular photograph, this is what you'd want. I want the details of the interior of the room to be apparent and visible, and that requires increasing their exposure. And then, of course, you still have the details available from the midtones and the highlights for the scene that's occurring outside the window. And so from a zoomed out point of view, you can already see some of the differences. You can see here on the left, the Nikon image is very clean. There's not much noise within the shadow. And even here, completely zoomed out, you can start seeing that cross-hatching pattern I discussed that shows up in the shadows on the Canon image. If I go ahead and zoom in, that difference becomes much more apparent. Nikon image on the left, you can see a little bit of noise, a tiny bit of blotching due to the deepest of shadows that were brought out and elevated. But on the right, you can see that there's a lot of this cross-hatching pattern, and you can see how obvious that pattern is relative to the completely random noise that's in the Nikon image. You can also see here on the Canon image, there's that blotchiness. Now, this isn't blotchiness from posterization necessarily. This is actually blotchiness as one of the side effects of this crosshatch pattern. Now, this crosshatch pattern is really caused because the individual channels on the Canon body are not perfectly matched. And so outside of the difference of noise that you can see in those channels, the difference in actual signals and how they're read off the sensor is different. And that's what creates this repeating crosshatch pattern of these vertical and horizontal lines. Some of the noise levels for those different channels are dropping below the threshold of what the raw processor like Lightroom can actually produce to recreate the color. And that's what's causing the blotchiness in this case. And so this banding is not just creating this luminance cross-hatching pattern, which is apparent and unusable in my point of view. It's also creating this blotchiness, which completely destroys the color rendition. If I scroll around the image and I go to even a deeper shadows, so you can see here, here's a portion where the bed meets the wall, where there's very deep shadows, where even after lifting the shadows, they're still completely dark within both images. You can see here on the left, the Nikon image, it's dark and almost appears as if it's clipped to black, meaning it's been brought down to be absolute black, but there's actually still some detail within that area, but there's hardly any noise, and there's absolutely none of that cross-hatching pattern and very little of that color blotchiness. Whereas if you look on the right, here the Canon image has completely fallen apart within these deeper shadows. You can see complete hatching, which has entirely overwhelmed the shadow area, as well as this blotchy color pattern. And so if I scroll around and look at more of the areas, you can see here throughout the entire image of what used to be the shadows, the Canon has that crosshatch pattern, whereas the Nikon doesn't, and the Nikon just has completely perfectly random noise, which is much more pleasing to the eye because it doesn't stand out like a pattern does. Random noise can almost be perceived as something natural to the scene, and something humans are accustomed to accepting in photographs, whereas a crosshatch pattern looks completely unnatural and the observer knows that it doesn't belong in the scene. So this is without any noise reduction applied. And in this case, what I've done is the shadows have actually been elevated by about 6 or 7 stops. And I achieved that in Lightroom by first adjusting the fill light slider all the way to 100%, which I think is roughly equivalent to about 5 stops of light. And then in addition to that, I've also increased the overall exposure by 2/3 of a stop. So again, I've pushed the shadows of this photograph by about 6 stops, maybe a little bit more than 6 stops. Then what I've also done is lower the exposure of the highlight areas, because when I increased the broad exposure by 2/3 of a stop, that produced clipping within the highlights where originally it did not have any. And so I needed to bring those highlights back to what the original luminance value was. And so what you have here again is almost appears as if the lighting was completely uniform across the entire image and blending those two lightings together. And it almost looks like a high dynamic range scene where you've blended exposures, because it's really producing that same effect of mapping all those different tones within the tone values that the output device can actually reproduce. So without any noise reduction applied, let's go ahead and see how well the images stand up to some noise reduction. This is the D5100 image, and I'll go ahead and zoom in. And you can see here, I'll go to the darkest area where the noise may be more obvious. And you can see the noise is really just the speckle patterns, which is the completely random luminance noise. There's not much color noise aside from some of that blotchiness. And so what I'll do here is I'll gradually increase the noise reduction slider for the luminance within Lightroom until it gets to the point where I think, from my own subjective point of view, where the noise is no longer visible. Now this is at 100%, so even though the noise was originally visible here, it may not be visible when you downsample the image when you print it, for instance, when you print it to an 8x10 print. And so it may not even be necessary to do any of this noise reduction. I'm only doing it here for demonstration purposes. So you can see here I've increased the noise reduction up to 20 for the luminance, and the noise is much less apparent. There's still a little bit noise within the shadows here, but it almost appears as if the shot was optimally exposed without pushing the shadows, because I've completely eliminated what I perceived as noise. And you can still see here that there's a lot of detail that survived that noise reduction. Again, noise reduction reduces noise by blending it in with the content, which necessarily reduces its detail. But here you can still see a lot of texture within the wall. And if I scroll to the comforter, you can still see a lot of texture within the comforter and all over the scene, all the way up to this other edge of the wall where there's also a lot of detail here. Now I'll try to do the same thing with the Canon image. All right, so here's the T2i image, and I'll go ahead and zoom into one of the deeper areas of the shadow. And again, you can see here how the cross-hatching pattern and that blotchiness has overwhelmed the photograph. But anyway, I'll try to reduce that by increasing the luminance noise reduction slider. And so I think I'll start at like 30, which is even higher than what I did for the 5100 image. And you can see the banding has softened a little bit, but it's still very obvious. And even worse, that blotchiness has actually become more apparent as I've increased the luminance, because I've reduced the detail, or the apparent detail, of that hatching pattern, which isn't really true detail, but just this false noise detail that's been introduced. So that makes the blotchiness of the colors even more apparent. So let me see if I can further reduce or eliminate that banding. So I'll go ahead and gradually increase this, and as I increase it, I get to the point where maybe about 70, which is a very high level of luminance reduction, the horizontal aspect of the banding has been almost eliminated, but you can still see the vertical aspects of the banding. And actually you can still see some of the horizontal areas as well. And now instead of it being completely luminance banding, it's really showing up as this color blotchiness banding, where there's actually a pattern to the color noise, which is even more unappealing. In my opinion, the color detail within this image is not usable in this form. And also, since I've increased the luminance noise reduction by so much, I've completely destroyed the detail, where there's now none of that texture in the wall remains. And then also, if I scroll to the comforter, there's now that smooth look where there's hardly any detail within the comforter that was there before. And I'll show you the difference if I go ahead and load back up the 5100 image and compare the two. And I compare the two, there's much more detail left in the comforter than there was in the Canon image after that noise reduction. And now I'll go to one of the walls, and you can see the difference of detail here. Here you can still see a lot of the texture and the natural color rendition within this yellow wall, whereas on the Canon image, you can still see a little bit of banding. It's very smooth because all that detail has been destroyed, and there's also that color blotchiness. Now I'll also show you the difference on this paper lamp here. On the right, you can see the gradations of white within the lamp on the Nikon image, and these are actual crevices within the actual light, and so a lot of detail there is being maintained. where on the left with the Canon image, that's all been smoothed out, where it almost looks like a flat piece of paper. Again, another demonstration of how the detail has been destroyed by increasing that luminance noise reduction on the Canon body. And I had to increase it higher to offset the banding that was in the Canon image, which is not present within the Nikon image. This is an actual real-world example of how the dynamic range, and particularly how the difference of the shadow performance between the cameras, manifests in the actual day-to-day workings of a photographer, where you're shooting these high dynamic range scenes with the intention of lifting the shadows in post. Well, with the Canon body, you really can only lift the shadows by maybe a stop and a half before you start seeing the negative effects of the banding and the noise. Whereas on the Nikon body, you can lift it up to 6 or 7 stops, depending on the content and your tolerance for noise and noise reduction, without any of those negative side effects. Now, one important thing I should note is that even though you can't see it, there's actually banding and noise both within the highlights and the midtones in the Canon image, because the read noise, which is producing that banding, and also the channel imbalances, is there for all levels within the tonal range of the photograph. It's just that within the higher ranges, the actual signal level of the scene overwhelms the noise, and so it's not obvious. But actually, if you were to do some different types of post-processing, for instance, increasing the contrast or starting to alter some of the colors, that banding on the Canon image would actually be visible within the midtones and even some of the highlights, depending on to which extreme you did that color post-processing.